Hey guys, today we're going to be using deductive geometry. We're basically going to be finding missing angles in diagrams, in figures. Here we're going to be looking at our diagram very carefully to find missing information that we need to work out our missing angle and to find it out. The example we have here involves parallel lines. Parallel lines, we know, are very important when we're looking at angles because they create special relationships. We know of alternate angles, corresponding angles, and co-interior angles. So whenever you're looking for missing angles and you can straight away identify parallel lines, think straight away, can I use corresponding angles? Can I use alternate angles? Can I use co-interior angles? If you don't remember what they are, go back to one of our previous lessons. We've covered corresponding, alternate, and co-interior angles in detail. Very important that you know the basics before we start here. Looking at this diagram, the question says, find angle BHD. Well, where is angle BHD? Angle BHD, BHD, this angle there. We need to find the size of angle BHD. The size is here. We need to know what is the size of that angle. Find the size of angle BHD, this angle there. We look at the diagram in detail and we look at it carefully. We look at it closely. Always I tell students, zoom in. When you're working with angles, you're like a detective. You have to look extra careful and be very careful with the information that you have. Looking at this diagram, we can tell straight away we have parallel lines. We can also tell we have 60 degrees on top. That's our clue. We're going to be detectives. We're going to be using 60 degrees to get to our missing angle here, and we want to find it out. Let's get started. We can see 60 degrees here, and we want to know how we can get from there to there. It's not as straightforward as jumping straight from here to here. There is no relationship that connects these two directly. So we have to find some kind of way to get from here and find this missing angle here. Always start by looking at the basics. We can see that this angle here, angle EFC, is corresponding to angle FHD. So FHD is there, this angle here, and that angle there. These are corresponding angles. Corresponding angles make an F-looking shape. You should already know what corresponding angles are. So corresponding, this angle here and that angle there are corresponding. We know corresponding angles are equal. So that means this is going to be 60 degrees. We have to write our working out. We write angle FHD, FHD, there it is, equals 60 degrees. What's our reason? Our reason is corresponding angles in parallel lines. Corresponding angles in parallel lines, that's our reason. Angle FHD is 60 degrees. We notice that these are corresponding. So this is 60. Now we are closer to our target, angle BHD. Well, we wrote our reason, we wrote our answer. This is perfect so far. This is 60 degrees. Now we want to know, can we get from here straight to there? Yes, we can. What do you notice? These two angles are supplementary. Supplementary, they add up to 180 degrees. This angle here and this angle there, they are sitting on this straight line. 60 and this angle here make 180. So therefore, angle BHD Are you watching carefully? Angle BHD, the one we're looking for, is 180 degrees. Take away the 60 degrees. This is totally 180 all in total. Take away the 60 here. We're going to be left with 120 degrees. So angle BHD is 120 degrees. That's the angle there. 120 degrees. So what did we do? We used supplementary angles. So that's our answer. We have to give our reason all the time. Supplementary angles. So this is our reason. That's our final answer. Angle BHD is 120 degrees. You must, at this stage, always show reasons for your answer. You have to give reasons. We found angle BHD. We started at 60. We noticed from here to here corresponding angles in parallel lines. That means angle FHD is 60 degrees, corresponding angles. Then we realized we can go from here straight to there. These are supplementary angles. If this is 60, that must be 120 because they add up to 180 degrees. Angle BHD is 120 degrees, supplementary angles. Again, you need to look at the details. You need to be extra careful when you're working these out. You need to know all the geometrical facts, like here we did corresponding angles and supplementary angles. You need to know them all. Now, let's do another example. Again, we are asked to find angle BHD. Angle BHD, where is it? It's right there. Angle BHD. We want to find it. We look at our diagram carefully. Hang on, once again, we have parallel lines. Straight away, parallel lines, we can straight away think, can we use corresponding angles, alternate angles, co-interior angles? Well, let's get started and see, depending on the information that we have. 110 degrees is this angle here. That's 110 degrees. We want to get from there all the way to here. Is there a relationship direct? No, there's no relationship that we know of that is direct from that angle to help us find it out. So we have to take maybe one or two steps. We can go from here straight to there. This angle and that angle. What relationship is that? It is alternate angles. Here and here, these two angles, angle BHC, H is for that vertex there, so BHC is alternate to angle FE or FCH. So this one here is alternate to that one. That means this is going to be equal. We know alternate angles are equal to one another. That means it's going to be 110 degrees, this angle here. So we have to write that down. We can't just work it out. We have to actually write it down as part of our working and our reasoning. So angle BHC, angle BHC is 110. Why is it 110? It is alternate angles. So we have to write our reason. Alternate angles in parallel, that's the parallel sign, lines. So angle BHC is 110 degrees, alternate angles. Very important, we are justifying our answer. We can't just give answers without giving reasons. Your reason is sometimes more important than the answer itself. You have to show the reason. So this is 110. We're looking for angle BHD. Let's not forget, angle BHD, that's what we're doing all this for. We're going from here to there, and now we're going from here to here. We know straight away these are supplementary. This angle here and that angle there, they are sitting on a straight line. That means they are supplementary. This angle and that angle are supplementary. They add up to 180 degrees. Supplementary angles add up to 180 degrees. So angle BHD angle BHD, what do you think it's going to be? It's going to be 180, which is a total. Take away this angle here. That means it's going to be 70 degrees. Angle BHD is going to be 70 degrees. 180 is the total angle there, supplementary angles. Take away 110, we're left with 70. What's our reason? Remember, 70 degrees is our angle. Our reason is supplementary angles, supplementary angles. This is very important. Again, we are working and finding missing angles, and here we have parallel lines. So deductive geometry using parallel lines, very important. We look for all the geometrical facts that we know of. We need to know our co-interior angles, our alternate angles, our supplementary angles, our corresponding angles. All the geometrical facts you learned in past years may be applied in deductive geometry. Here we've specified and we looked at specifically angles and parallel lines in this case. Very important that we show our working out. Very important that we become like detectives. We look at them carefully, we look at them closely, and we work step by step. Don't panic, look for clues, and you'll notice it's pretty easy. Show working out, give you a reason, show working out, give you a reason, and you get your final answer. Pretty simple.